Alrighty then. This is a good interview style problem for those of you applying for maths at university at the undergraduate level. If you have to sit an interview, this is a good interview style problem. I got this problem from a sort of booklet of problems, not the TVO booklet, but essentially another booklet called the International Mathematical Talent Search. Essentially, if you search that up, the International Mathematical Talent Search, you will probably be able to find the website, and on that website there are two PDFs, so two booklets of problems, and I would check those out. Some of them are easier than others, but they're generally quite good. And this is the first problem from the first booklet. Actually, this isn't even the first problem. Actually, I guess it is. But I'm only going to be dealing with the first part of the first problem, which is dealing with the two-digit case of this problem. You can think about the 3, 4, and 5-digit cases yourself, as in those are going to be left as exercises, I guess. But yeah, I mean, this is really good. Definitely search it up, the International Mathematical Talent Search, and you should be able to find those PDFs. Okay, so first things first, let's just read the problem. For a two-digit positive integer n, s of n is defined to be the sum of the digits of n. So for example, if n is 18, s of n is equal to 1 plus 8, which is equal to 9. We're asked, what is the minimum value of n divided by s of n? And then I've left it as a bit of an exercise, I guess, if you're interested, to find the minimum value of n divided by s of n for n, which are 3, 4, or 5-digit positive integers, essentially. So deal with each of those cases separately. But in this video, I'm only dealing with the two-digit case, which essentially just tells us the following piece of information, that 10 is less than or equal to n is less than or equal to 99, because I've also specified that leading zeros are not allowed, so 0, 2 is not a valid option for n. Okay, so we have a bound on our n, and at this point, I guess we can kind of just get straight into it. Okay, so in terms of the possible digit sums for two-digit integers, or for values of n between 10 and 99, obviously, well, we have two digits, a and b, and the maximum we can actually make those digits, the maximum value of any of those digits is 9, right? Because you can't have a digit of a number greater than 9. And so essentially, the maximum value that we're going to be able to make the digit sum is 18, in the case where a and b are both 9, right? And so 99 is the two-digit number with the largest digit sum, which is 18. And because we know that 18 is the largest digit sum, which is achieved by making both a and b 9, then you know, we now have a sort of range for our possible digit sums. Okay, we also can't have 0 as a digit sum because, well, 10 is the smallest number here, and the only way that we would possibly be able to make 0 is if we had two zeros, right? Because you have two digits adding to make 0. If one of them is not 0, well, there's no such thing as a negative digit. So if one of them isn't 0, then it's impossible to make 0 as the sum. So essentially, we therefore have that given that n is between 10 and 99, we know that 1 is less than or equal to s of n is less than or equal to 18. Okay, and what I'm going to do is I'm going to deal with two separate cases, and it will become clear why I'm separating the cases as I'm doing here. So the first case I want to deal with is the case whereby s of n is between 1 and 10. Okay, so essentially what I'm doing here is I'm considering all two-digit numbers whose digit sum, or the sum of their digits, is between 1 and 10. Okay? Now, that's obviously not going to be all two-digit numbers, because we have 99, 98, numbers like that. But I'll deal with those other numbers later. Now, essentially, what I'm trying to do, what I'm actually considering here, is n divided by s of n. Okay? And we can call s of n a fixed value s, right? We can just fix s of n, right? So let's say that as a value, call that value s. And once we fix that value, we then have that the expression n divided by s of n is just the same thing as n divided by s, where s is fixed. Okay? So, for example, I might be considering the case where s of n is equal to 8, in which case this s here is 8. So at this point then, we have to basically minimize the value of n, right? Because given that s is fixed, the smallest possible value this fraction can take occurs when n is as small as possible, right? Because s is fixed. So even though I'm dealing with a range of values here, like this case is going to work for all of the possible two-digit numbers whose digit sums are between 1 and 10. So I'm dealing with a range of possible things. I'm fixing for each of those individual cases my value of s of n, right? So for example, that could be s of n is equal to 1. as one case. And then essentially the procedure that I'm going to use for that specific case is also going to work for s of n equals 2, 3, 4, 5, all the way up to 10. So I don't actually need to do an individual thing for each of those, but I do need to fix my digit sum. Okay, so I've kind of gone from working with a range of possible digit sums to specifying which digit sum I'm dealing with, just so that we can consider this fraction, whereby the denominator s of n is a fixed number or is constant, essentially. So in order to make this fraction as small as possible, because s is constant and n is changing, well, obviously, to make this fraction as small as possible, we have to make n as small as possible. So the question then is, given that the digit sum of a two-digit number is s, what is the smallest value of n with that digit sum? So we have to construct it, basically. And, well, we already know that we have a two-digit number, so it's of the form ab, or 10a plus b, in base 10. Okay? And we know that a plus b has to equal s. And intuitively, it's going to be better to put a larger proportion or a larger amount of this s into the units digit of our number to make it as small as possible, right? For example, if the digit sum of my number is 8, let's say that a plus b is equal to 8, then I want to put most of this, if not all of this, on my units digit, right? Because if I were to make a equal to 0, a equal to 8 and b equal to 0, then I get the number 80, which is very, very close to 99. So it's quite large. It's quite a large digit number. However, if I make a equal to 1 and b equal to 7, then I get the same digit sum, but a much smaller number. And that's because I've essentially put most of this s into my units digit, into my b value. I can't put all of it because I'm not allowed to have leading 0. So I can't have a being 0. Okay, so I can't put all of the value of s into my units digit, because then I would have to have a one-digit number. So it's not going to be a two-digit number. But I can put most of it into my units digit. And essentially, 17, in the case where s is equal to 8, it should be quite obvious that 17 is the smallest two-digit number with digit sum equal to 8, right? Because, you know, we can't have a equals 0, so the next smallest value of a we can have is 1, and then given that a plus b is equal to 8, that then forces b to be 7. Okay. So, in general then, if a plus b equals s, then the smallest two-digit number, which is going to have digit sum equal to s, is going to occur when a is equal to 1, and b is equal to s minus 1, right? Because a plus b has to equal s, and we want to make a as small as possible. So the smallest value we can make a, because we can't make it 0, because we're not allowed to have leading zeros, is 1. And so therefore the sort of largest value of b would be s minus 1 to make a plus b equal s. Cool. So therefore the smallest value of n is going to be 10 times a plus b, right? Because that's what this two-digit number really means in base 10. And so the smallest value of n for a fixed s of n equal to s is 10 times 1 plus s minus 1, right? Because we have our 10th digit being 1 and our units digit being s minus 1. So in base 10, that's the same as 10a plus b, or 10 times 1 plus s minus 1, which is exactly the same as s plus 9. Okay? So now, for each fixed value of s, we have our smallest possible value of n, as long as s is between 1 and 10. Okay? Because if s, the digit sum, is, say, 13, then this isn't going to work, because I can't have a digit being equal to 12. So I can't set b equal to 12. Okay, so we're going to have to come up with a different strategy, essentially, for the case where s is between 11 and 18. And maybe you can think about that strategy before I actually get to it yourself, if you haven't already. But essentially, because we know that s is between 1 and 10, we know that s minus 1 is going to be a valid units digit. But if s was 13, then s minus 1 is 12. That's not a valid units digit. A digit of a number can't be 12. The digit has to be between 0 and 9. Okay? Cool. So we know that the smallest value of n for a fixed digit sum is s plus 9, and so we want to, essentially, for the cases where s is between 1 and 10, minimize n divided by s. So n divided by s is equal to s plus 9 divided by s, because we figured out the smallest value of n is s plus 9, right, for a fixed value of s. So the smallest value of n divided by s will be s plus 9 divided by s, which is 1 plus 9 divided by s. And so essentially, then, we know this is the smallest value of n divided by s for a fixed value of s, and now we want to consider the options for s, which are between 1 and 10, right? Because this case is considering all values of s between 1 and 10. So if we want to make this as small as possible for values of s between 1 and 10, then we need to make s as large as possible, right? Because then, essentially, this fraction here is going to be small. As you make the denominator bigger and bigger, this fraction gets smaller and smaller. So you want s to be as large as possible to make this fraction as small as possible. So you are adding the smallest possible thing to 1, okay? And so essentially, the largest value of s that we actually have between 1 and 10 is 10. And so essentially, the minimum value of this quantity is going to be when s is equal to 10. And the minimum value of n on s for 1 less than or equal to s less than or equal to 10 is 1 plus 9 over 10, which is 19 divided by 10. Okay, so that's the first case, and then we can kind of go through the second case decently quickly here. So because we know s of n has to be between 1 and 18, then the second case is going to be dealing with values of s of n between 11 and 18. Okay. And in this case, if we fix s of n, again, so if we fix s of n equal to s, then obviously n divided by s of n is equal to n divided by s, and s is fixed, so we want to make n as small as possible. And so essentially that's the same thing as making this two-digit number ab, or 10a plus b, as small as possible, given that a plus b is equal to s. Okay, so we obviously already know this from the first case. But this time, s is greater than 10, so we can't just set b to s minus 1 because then we're not going to have a valid unit digit. Okay, so this time we have to sort of switch up our strategy a bit, but we still want to put as much of s as possible into b, right? And because we know that s is between 11 and 18, that means that the largest value of s, the largest sort of portion of s we can actually put as b is 9, and then the remaining s minus 9 can be a, right? Because we have to split s into both a and b, right? We have to do that. And unfortunately, we can't put all of s on b, right, because a would be 0. But we also can't put s minus 1 on b either in this case, because it's not a valid units digit. So, the largest sort of portion of s that we can put on b, because s is between 11 and 18, is 9, right? Because 9 is always going to be less than s, okay? So we can always put 9 on b, and we can't put any more than 9 on b anyway, because that wouldn't be a valid digit. Okay, so we have to just put 9 on b to minimize n, and then the remaining s minus 9 is going to go onto a, okay? So that the digit sum is s. Okay, so the smallest value of n for s between 11 and 18 occurs when a is equal to s minus 9 and b is equal to 9. Cool. And in this case, 10a plus b is going to equal 10 times s minus 9 plus 9, which is going to be 10s minus 90 plus 9, or 10s minus 81. Okay, and this is equal to n. Okay, so this is what? The smallest value of n. Value of n with digit sum s, where 11 is less than or equal to s is less than or equal to 18. Okay. And at this point then, what we were initially considering is the minimum value of n divided by s of n, and now we know exactly what that is in terms of s. So minimum value of n divided by s of n is going to be, essentially in this case, 10s minus 81 divided by s, when s is between 11 and 18, which is 10 minus 81 divided by s. Okay? Now, this time, because we have a minus sign here and s is positive, to make this as small as possible, we want to make s as small as possible, right? Because we want to subtract as much as possible from 10 to make the smallest possible number, right? However, we have to have s between 11 and 18, because that's the case that we're working with here. So we can't have s being any smaller than 11, sorry. We can't have s being any smaller than 11. And of course, the smaller the denominator, the larger the fraction is here, because the numerator is constant. Okay, so essentially the smallest value of n divided by s of n is going to occur when s is equal to 11, because that gives this being the largest possible thing, and then 10 minus that being the smallest possible thing. Okay, so min value of n on s of n for 11 less than or equal to s less than or equal to 18 occurs when s is equal to 11, and it's 10 minus 81 divided by 11, which comes out to be, I think, 29 divided by 11. Because 29 plus 81 is 110, divided by 11 is 10. So there we go. At this point, we now have two values, 19 on 10 and 29 on 11. And all we need to do is compare those two, because essentially we've considered every single digit sum, and we found that the smallest possible values for n divided by s of n, when s is between 1 and 10, is 19 on 10. The smallest possible value of n divided by s of n, n divided by s of n, when s of n is between 11 and 18, is 29 on 11. And then whichever is the smaller of those two is the smallest overall, right? Because we have two separate cases. Now we're joining them together to find which is the smallest overall. So all we need to do is compare 19 on 10 to 29 on 11. And, you can sort of compare them without necessarily having to use a calculator or anything like that, right? Because you can say, okay, 19 on 11, question mark 29 on 19 on 10, question mark 29 on 11, multiply both sides by 11 and 10. So that gives you 19 times 11, 209, question mark 290, and obviously 209 is less than 290, so you know that the question mark at the beginning also had to be a less than, right? So you can kind of do this without a calculator by just sort of multiplying both sides, so you get two integers you can compare, like this. And then at that point, you know that the inequality sign is less than, and so you know that 19 on 10 is less than 29 on 11. Precisely, 19 on 10 is obviously 1.9. 29 divided by 11 is 2.63, recurring, so on and so forth. And so 19 on 10 is going to be the minimum possible value of s divided by n. Okay, so 19 on 10 is min n divided by s of n for n in the positive integers, n 2-digit. I'm running out of space. Okay. Okay, so that is the answer when n is a 2-digit positive integer, but what about when n is a 3, 4, or 5-digit positive integer? But I'll let you guys think about that one, and if you do get an answer, let me know in the comments. If you have another way of doing this problem, also let me know. I'm sure that there are better ways of doing it, but yeah, this is the way which I am choosing to present. Okay, cool.